You will get a version of this shortly. It's basically giving you a rundown of the questions that you will be meeting in your final. So let's do the big picture about the final. I'll talk just a little bit after that about the test, and then whatever time we've got left, it depends how many questions we get. I'll try and answer any other questions we have. If you look really carefully, do you notice that we don't do any of the numerical integration? So in the final exam, you won't have to do Simpson's rule or trapezium rule or the midpoint rule or whatever, right? We've already done those and tested them, and they take forever in a day, don't they? They're quite time consuming. So they're not there. So your questions in your final will be chronological. So the first thing you'll see is what's called the definite integral, which are really things like 5x cubed e to the x, and various functions that you should know how to find the integral of. Substitution, u-subs essentially. Areas between curves, shell method and cylindrical method for volumes. What does work involve? What was the section 6.4 work about?
Pulling things up buildings.
That's it. For no particular reason, pulling buckets with holes in them and water going up buildings. There was another subgroup, a different group of questions inside work. Can you remember what that second topic was?
Springs.
Springs, called Hooke's law. So if you look at your homework questions and so on, you will get an idea of what these guys look like. Okay. Now, I'm telling you now, and I'll hopefully you'll watch the video as well. On the day of the test, all access to everything else in WebAssign will be closed off. And the reason, one of the major reasons for that is that most of your test questions are basically just going to be revamped WebAssign questions. And so I don't want you to be just saying, oh, well, I'll just go and look at my homework question where I did that one and it's the same question and figure out what to do from there. So you won't have access to those features. All you'll see is WebAssign will just have one thing free, and that one thing free will be your final exam. So bear that in mind. Right, moving on. That's chapter 6 done. Chapter 7 is mostly about integrations techniques, integration by parts, trig, substitution, rational functions, and then improper. So let's show you what that might look like. Right, here are 3 integrals of a similar kind of look. I'll give them names. I'll call them A, B, and C. Which one of these is the u-sub?
C.
Correct. What feature made you go u-sub?
The power, the x squared.
This guy up here. And if you use, I'm assuming that was obvious, that is your u-sub, it would work, right? Now, if you look at this guy, and you look at this guy, can you see how the U sub wouldn't work? You might say, well, I could do a U sub. I'll do U equals X. If you did that, won't the integral just turn into UE is a U du, in which case you've done nothing? So since these two are both integration by parts, let's choose this one to kind of work on. What would you choose as the F in question A?
X squared.
And correct. What made you go that road? What you have to make a decision, don't you, when you do integration by parts? One of them's got to be F and the other one's going to be G, right? And just like in U subs, there are big rules that cover 90% of the situations, and then there's special cases, right? In this case, it's a pretty standard one. So what would be why did you choose the F and G that we did?
Because using x squared as the F makes x squared get simpler.
Right. So x cubed sine x, x squared, I can't think of anything else. Secant squared x, something like that, right? Whatever. Good choice. Now, still on integration by parts or U subs. U sub or integration by parts. What's that guy?
Integration by parts?
Agreed. Would you agree that a U sub is almost like a non-starter? It doesn't even have a look that a U sub would be any use for, right?
Mm-hmm.
Now we've got to pick the F and the G. And this one is not, well, I don't want to say anymore. Who is the F?
Is it the natural log of x?
Right. Correct. When we've done these before, hasn't the log been one of the special case things? Because there's this backup rule. The first rule is pick F because it gets simpler when you differentiate. But isn't there another rule that says if you can't integrate the thing, make it F?
Mm-hmm.
And that's why I would choose that. Now, just to complete this particular question, I'm trying to think of, okay, I'll pick the baby one because I can't think of a better one right now. Wasn't there a special group of questions? Oh, just thought of some more now. Like these two, where you are still going to use integration by parts, but there's only one term. And so there was a workaround on how to alter it so that it could be integration by parts. And it's a very simple fix. Can you remember what the fix was in questions that looked like this?
Multiply by 1.
Right. You still have to pick an F and a G, don't you? So in this one here, you pick that as the F. In this one here, oops, can't do my writing. You pick that one as an F. In fact, whenever it is a single function, right, a log x on its own, an inverse sine on its own, whatever it might be, and you're using integration by parts, don't you always pick the single function as being your F? And that's working on the rule is if you can't integrate it, make it F. Right? If you don't know what its integral is, make that guy the F, which makes 1 the G. This one's quite interesting because after you do it, you end up having to do a substitution as well. So not only do you do a U sub, you then have to do a substitution method after that just to get the answer. I believe what you get is x over the square root of 1 minus x squared, and the u sub ends up being 1 minus x squared. So it's quite a convoluted one, that one. Okay, so in the u sub world, aren't there obvious u subs and special cases? I don't need to spend time. I could, but I'm looking at my watch here and time's zooming by like nobody's business. So let's return to the list of topics. Can you remember the arc length was the square root of 1 plus the derivative squared dx thing? Remember that one? Arc length. The areas of, oops, did I miss something? Yeah, I did. God, yeah, I shouldn't go to that yet. Trig integrals. A lot of trig intervals are going to use two techniques, one of two techniques. So let me show you what a trig integral question looks like. It's one that involves, pretty obviously, trig. And it's very often u subs or identities. This is a u sub. Who do I choose as the u sub?
Sine.
Agreed. And can you trust me that if you did that, it would become a u cubed du? What would happen if I chose cosine? Well, if you wanted to, eventually you could fight your way through and get the correct answer. But if you chose cosine as a u sub, you'd only eat up one of these signs and use some other stuff to deal with. So it's for efficiency, right, to make your life easy. If you have two guys and one of them is, in this case, got a larger power than the other, isn't that typically a u sub? How about this fella? Who would I use as my u sub this time? And that's the cosine to the 11 power.
In this case, would it be cosine?
It would. And can you trust me that when you're finished, you eat up one of those signs, and there's a little negative caused by the derivative part, you end up with that. What is going to happen is there's going to be some sign, in this case, some sign squareds left over. And you know when you do u subs, you're not allowed to have two different variables at the same time. Aren't we going to have to figure out how to turn sine squared into something that uses cosines? And that's going to be what is happening here. What is sine squared in terms of cosine or cosine squared? Bear in mind what you want is cosines, nothing else, apart from numbers.
Isn't it 1 minus cosine?
Yes, it's that guy. Which basically means 1 minus u squared, right? So what you've got is a negative, a 1 minus u squared, a u to the 11 du. What do you think you would do next?
Distribute?
Okay, so you end up with, I hope, those two guys. Would you agree that's just a power rule?
Yeah.
The answer, I hope, is that guy, right? And if you type that into WebAssign, it would say you were wrong. Because I've forgotten to do one more thing. What should I do to get the correct? That's 90% right, but what should I do to get 100% right?
You gotta put your cosines back in.
It's those little, I guess, details that are the things that catch people out. Which brings me to why, when you do your test, and especially when you do your final, that you make sure that you show all the working. Because if you plug in that, WebAssign will just say 0, and that's it. You've just lost 20 points because there's 15 questions in your final. And not a good idea, right? But if you can show me your working, well, in fact, even if you didn't show me that, would you agree that that is 90% right? So you should get, you know, whatever it is, 17 points or so on. So you'll get almost all the points because you did it almost right. So show your working, show your working, show your working, right? What would you do? Because there's two techniques in this. That is not a use-up. That is an identity issue. In other words, you choose to rewrite this in another format that will make it possible to get the answer.
Double angle.
And it's 1/2, 1 minus the cosine of 2 theta, which ends up being this fella here. And that gets you a 1/2 theta, and that'll get you a 1/2 with another 1/2. Are you happy where this extra 1/2 came from? It came from the 2 theta bit. Now, we're just kind of touching on little bits of the puzzle, and if I had 4 hours, I still wouldn't cover everything because it's 10 weeks worth of work. It's impossible to cover everything. But I'm just covering those little things that, in my opinion, cause issues. Now, trig substitution. These are guys that look like this. And trig substitution, I prefer to call it X subs. Take one of the following 3 forms. For that question, which one of those 3 is the right one? So when you come across a question like this one, which is certainly a good example, it's getting you to pause. And if you have to pause and say, oh, I can't remember, wouldn't that be a good topic for you to spend some time revising? Now, there's a 4 there, which makes these guys 2. If it's an x squared plus 4, you're going to use that one. If it's a 4 take away x squared, you're going to use that one. And when it's an x squared take away 4, you're going to use that one. So what you might want to do is write down on maybe a separate piece of paper with a heading, I don't know, X subs or trig subs or something that is easy for you to find. And then when you come across a question, if you did get one in the final, you'd say, oh, this one, and then off you go, right? So if it's, you know, the little details, you might, depends on your brain and how you memorize things. Maybe you could write down little rules to yourself about U subs. The thing inside the square root is a good candidate for a U sub. The thing inside the big brackets is a good candidate for the U sub. If you see a log somewhere, it's probably going to be the U sub. You know, little notes to self like that. You won't get all those three. You might not get any of them, but you might get one of them. So, you know, if you can write down things and have them easy organized, so you don't spend half your time going through 50 pieces of paper, because then it becomes too big and cumbersome. But you have it in easy to find format. That would be a suggestion. Oh, let's suppose I did one of these and the final answer ended up being sine squared theta plus 3 cosine thetas. And suppose then that it was 2 tan theta, right? Well, let's just say for argument that's what it came down to. That is not the answer, is it? Don't we have to convert it back to x's? How do you convert these into x's?
Build a triangle.
And the triangle looks like that, with opposite, adjacent, hypotenuse. And this fella is how you populate it. Right, a quick divide. Now, a tangent is opposite over adjacent. So this is x, and this is 4. And this guy here, by Pythagoras, is x squared plus 4. And secondly, the third triangle is always a clue to you've done it right. Do you notice that this third triangle is him? The third side of the triangle is him. If this third side ends up being x squared minus 4, or something not even vaguely like it, the bad news is you've probably chosen the wrong one here. But the good news is you now know that. So you should hopefully say, okay, I can fix that. Because you do get an extra hour, right? More than you typically should need. Not all your 15 questions are going to be equally long. Can you imagine I could just give you x cubed plus e to the 4x plus 5. Right? That'll take you a minute, right? But that's one of your 15 questions. And then this massive question will take you a lot longer. But between the two, it kind of averages out, right? So some questions are easy, some questions are not so easy. And I probably used too much time, but you know, I think that's important. So don't be surprised if you see one of these. What else we got? I'll have to do a superficial on this one. You won't be told what the section is. You'll just be told find the integral. Most of the questions are quite short, right? Do you recognize that as what they call, what I would call, I think they call it as well, a partial fraction question? And so you're going to split it like this, right? And we'll just cut to the chase. After a few lines of working, you end up with something that looks like this. What is the next step in this process to find A and B?
Choose a value for x that will get rid of either A or B.
And in this particular situation, do you agree it doesn't really matter which one you pick? So in this simpler version, it's easy. In this sense, won't you pick x equals 3 and then x equals -2 and boom, you got your answer, right? Well, at least you've got two fractions, but won't both of them just be logs? So you're almost done. I want you to imagine a different story. Something like that. Imagine, oh, it can't have B there, you have to have a different letter. In questions, especially the ones that have AX plus B in them, you still pick X's, right? Actually, I think that's probably going to be more likely that, right? You still pick X's, right? But isn't it now much more important that you choose them in the right order? In other words, one value of X should happen before any of the others. In this question here, what would be the first value for X?
3.
Correct. You want to explain to the people who are watching thinking, well, why didn't you pick 0? Or why didn't you pick -2? Because they were candidates, right? I could have picked them. But you chose 3. Why?
Because 3 will take away both A and B, giving us only C.
So the trick is to pick an X that makes it happen. Now, I'm not even going to try and solve that one. Can we pretend that I solved it and I found out that C was 4? Well, 7 then, right? In this kind of question, when you find somebody, don't you rewrite the equation, but with the letter replaced by a number? That's part of the process. You've got to do that. Now, look at that ugly guy. Who should you choose now?
Zero.
Correct. Want to explain for the others your thought process?
0 will take out the A, so we'll only have B left over.
And that doesn't matter because that'll be a number, right? So we don't care about numbers. But you see why that's a number, because C is now a 7. If you left that as a C, wouldn't you end up with a C in your equation and get all confused? Right. Now, once you've got that, and I'm just going to pretend that A is 10, because I want it to be. There's only one guy missing. Isn't the guy that's missing B? Who do you choose this time?
Anything you want?
Yeah, except probably 3. Agreed? But pretty much anything you want. And you got all your guys. Now, that's another long question, but you see that there's a whole process to this one, right? And it's hard to describe processes, right? You can't really write notes down in any easy way that says, this is the process. But you could do an example of a question like the one I've just did, and then maybe in red pen, write down why you were choosing this number, right? Like what Sam and what Kathy were saying, so that when you see a question that's like it, you'll say, oh, okay, I got to pick an X, but I just can't pick any old X. I got to pick an X that makes everybody go away except one letter. You know, in some kind of sentence that doesn't even need to be grammatically correct, but it has to make sense to you. So that when you read your little card about how to do these kinds of questions, you're saying, oh yeah, I remember that question. I got the process. Any questions right now? Because we are kind of running out of time quickly. Anything about the test final you're not sure about?
If possible, if we have time, could we go over one of those work problems with the leaking bucket?
I'm writing this down. Yes, I will do, for those who are interested in seeing a leaking bucket question when this class is officially finished. So if you want to hang about, you can do it. Otherwise, just watch the end of the movie and you can see it. Hey, I just got this a movie. Hey, we're in a movie, guys. I didn't even know it. God, that distracted the heck out of me, that thought. Okay. Where are we next? Well, let's turn back and talk a little bit about the final, as you can see here. I think we can see it. Let's double check. I'm not even sure where we are anymore. Here we go. Improper integrals. Do you know those are the ones with the integral from 1 to infinity of 1 over x squared, things like that? Or that's type 2, now I've got the name in my head, or the integral from 2 to 3 of 1 over x minus 2. Right. Arc length, kind of formula really, isn't the arc length just the square root, or well, the integral from a to b of the square root of 1 plus the derivative squared dx. Algebraically, when you do those questions, don't you get a number inside the square root if you're really lucky? That would be a short question. But don't you sometimes get perfect squares? And not always the nicest looking perfect square in the world. Remember those ones that were a half x to the 4 plus a half minus a half x to the negative of 4, right? Some really weird looking combinations. How do you know that a square root has a perfect square inside it? There is a way of telling that it's a perfect square, even if it doesn't even look like it.
When you have 3
terms inside. So if you see a square root and it's got something, you know, x cubes, don't care what the sum's in, right? Something plus something plus something, right? If that is inside the square root, it better be a perfect square or you can't integrate it. You know, it's just impossible to integrate, right? So that is a truism that's also true for the surface area one, which is 8-2. Because the only difference in that, don't you have different formulas depending on rotating an x axis using x's? But don't you also have a formula rotating in the x-axis but using y's? And then rotating in the y-axis using y's, but also rotating in the y-axis using x's. All of them are going to have a square root bit to them. And the types of questions that you're likely to see there are perfect squares inside the square root, or u subs, where the u is the thing inside the square root. That's the most likely algebraic versions. Applications in physics. Oh, glad I remembered. Someone asked me, is 8.3 in? And the answer is no, 8.3 is not going to be in the test now. I changed my mind. So to make it clean and kind of compact, we are going to test the other topics in the final, so it's not like I'm skipping them. But applications in physics. Can you remember the 2 main types of questions that were in 8.3? So this is more for the final, not for the test. There were 2 basic kinds of questions that we did in the applications of physics.
Center mass one.
Right, the x bar, y bar, and
Hydrostatic pressure.
right,
Pressure.
plates under the water. Remember those guys? Remember the triangles and the rectangles, and oh God, remember how ugly that half circle was. Remember that guy? Makes you cringe. Those guys, hydrostatic. Right, so your test is only going to be chapter 9. Your test is 2 hours, as always. It's optional. If you've got 4 good tests right now and you know in your heart that you're not really going to improve on your grade, you might want to just not bother doing the test. It is optional. And you could spend that time getting ready for your final. That may be a better usage of your time, because your time is very valuable right now. Okay. You might decide to just turn up for practice, just to see what questions look like, because you might see things like it in the final and you just want to get a feel for, you know, what they look like, right? And you might look at it and say, oh God, no, I don't want to do this, in which case you just say bye-bye. You'll probably get 0 for the test, but since it's the best 4, it still won't hurt you, right? So it won't hurt you if you do it, right? But I don't want to make you say, oh, you must do this test, because if you know yourself, you're always getting 85 to 89 every time, and you're probably going to get 85 to 89 again. It's not going to change your grade, is it? So it's maybe not the best use of 2 hours. But your choice. If you turn up, you get attendance. If you don't turn up, you're getting attendance. So it's not even going to affect that. There are going to be, I believe, 10 questions. The 9-1 modelling are going to be pretty straightforward. Here is a differential equation. Here is a function y equals x cubed plus sine x. Is it a solution? Yes or no? Yes or no? So in those questions, I guess you could just get lucky and guess. Good idea to do working. The second version of that question is, here is a differential equation. Here are 5 equations. 2 of them work. Find the right 2. They won't tell you it's 2. It could be 3, it could be 1, it could be none. But that's what you do. The only question you're getting in 9.2 is, here is a guy, which one of these 4 pictures is the direction field? And I've got the software for that. Don't you just type it in and look at a picture and compare it against theirs. So that'll be a really, hopefully, quick question in 9.2. And then variable separable and linear. And in both of those cases, there'll probably be an easy one, an average one, and a harder one. The harder one will probably have a boundary condition, y of 0 equals 4 in it. And for the linear, the same kind of things, right? Any questions about that? Okay, final and test, essentially the same format. They'll be in WebAssign. There'll be a Zoom meeting, so I get to watch it, make sure that everything's correct. When you're finished, you get that half-hour time slot in both cases to take a copy of your working and upload it into Canvas. So think of the finals just being a big test. Final is 30% of your grade. Really a biggie. So you make sure you're as prepared as you can be and that you show every darn bit of working you can think of. So if you get a mistake, at least I can check your working and give you as much partial credit as possible. Any more questions? Have I covered everything you want as far as the general stuff? Okay, say hi for attendance. Those who are interested in the leaking bucket will hang around and I will do a leaking bucket question. Those who have other things to do can do so. If the time for the final doesn't work for you or for the test, you tell me and we'll fix another time slot for you. Okay, last chance. Okay, bye-bye to most of you. Those who are hanging around, that's cool too. I'm going to have a cliff, right? I'm going to have a little guy. Okay, we'll do it in feet, make my life easy. How tall do you want the cliff? Chuck in a number.
50 feet.
Right, now we have a bucket with some water in it and a leak. Okay, so we're going to be given information about all of those things. How heavy do you want the bucket to be?
£10.
The rope has a weight to it, and the rope is always, in this case at least, per foot. So how many pounds or fractions of a pound per foot is the rope going to weigh?
Three.
Now we're going to have the water. The water is going to be a little bit trickier. I'm going to have that there is, just to make it awkward, 75 pounds of water in the bucket. But only at the start. And the question is always kind of phrased that says something along the lines of, isn't the water leaking out of the bucket in such a way that it's empty just as it reaches the top? Agreed? Right, so what we have to do here is we have to set up a variable that represents this position in the journey of the bucket from the bottom to the top, right? A variable x. And we can decide to call x the top to the bucket or from the floor up to the bucket. If you do whatever one of those two you do, you're still going to get the same correct answer. If you choose it one way, some of the calculations, some of the bits are going to be uglier than if you choose the other way. But it really doesn't matter as long as you go through the process. So do you want me to do x from the top to the bucket or from the floor to the bucket? Which do you want x to be? It's not really what do you want it to be? Since both works, it doesn't matter.
From the ground to the bucket.
Okay. So let's assume that we do this guy is x. So we have to create what's called a force function. The force function is, pen is useless, is made up of three things. The bucket, the rope, and the water, right? We're going to figure out what these guys are, and then once we know that, won't the integral just, oh, sorry. I will, if you don't mind, I will pause you for a minute and mute. I'm pretty sure you don't want to hear your private conversation. Right, we're back again. Okay. So, isn't the bucket £10? I'm just talking about the bucket on its own, nothing to do with the water inside it. The rope's going to be a little bit awkward. I know that is X, but isn't the weight that I'm pulling this side? Right, that's the weight of the rope here, right? So if I make that guy X, then won't this distance here be 50? Take away X. And how much does 1 foot of rope weigh? It weighs 3 pounds per foot. So if that's how much rope there is, 3 times that distance is the weight of that rope. Okay. Now, the water is definitely going to be the ugly one. At this point here, right, if you think about it, what we need to calculate, I guess I'll keep it in red, is the rate at which the water is being lost. So for every foot, how much water is going to leak out? Well, we know that there is 75 pounds of water, right? And we know that there's 50 feet of cliff. So wouldn't the rate at which it's being lost be 75 divided by 50? So for every foot of distance, you will lose about 1.5 pounds of water. Are you comfortable where that 3/2 came from? So for every foot upwards, you lose a 1.5 pound, another 1.5 pound, another 1.5. By the time you get to the 50-foot mark, won't you have lost 75 pounds, all the water? Okay. Now, this is X. So how much water have you lost? Well, X feet times that is 3/2x. Agreed? Now, how much water is left is not the same as how much water you have lost. How much water is left is 75 take away what you lost. Are you comfortable with the bucket, the rope, and the water? Have you seen in this particular orientation, these two have been slightly ugly? If I'd chosen the X this way, they would have been a little bit nicer looking, but it wouldn't matter, not in the long run. So 10, distribute. $50, 225, 235. Take away, convert this into halves, or 6, take away 9 halves x. There is my force function. And the work done then is from x equals 0 to, what, 50 feet of the force function. And aren't these typically really ugly big numbers like 82,500 and so on? So you're not going to be too concerned when you get huge answers.
Can you move the paper up?
Is that enough for you?
Thank you.
We good?
Thank you, that helps a lot.
Like a lot of these types of standard questions, right? The ones that you see 2 or 3 examples of. For me, I find it helpful if I kind of just have a kind of systematic approach. Because I'm a visual learner, I need this picture. It helps me figure out what's happening, right? What goes where. If you didn't have this, I think it's much more difficult to create some of these pieces, especially these. So pictures are good, right? I think in many cases they are. If this question had no leaking water, wouldn't the answer just be those two guys? Well, I guess plus 75, right? Because there's water in it, right? If there was no water at all, then it would be this guy, right? If they change the weight of the rope, doesn't that number change? So, I mean, you can make the bucket heavier or lighter, the rope heavier or lighter. You can have water leaking, or just have it full at the top and at the bottom.